Welcome learners, my name is Dr. Kapilesh Vansalkar, Assistant Professor in Physics, Ganpat Parsikar College of Education. Course entitled Everyday Physics with Demonstration. And the topic is the wonder of sounds. So let's begin with wonder of sounds. Radiation, any process in which energy emitted by one body travels through a medium or through space, ultimately to be absorbed by another body. The radiation includes sound, light, and nuclear radiation such as alpha, beta, gamma, positron, or neutron. Making a sound source visible. Vibrating tuning fork touches to a beaker of water or against a suspended ping pong ball. You can just see the vibration of water. A candle in front of vibrating loudspeaker. You can make out the sound visible. Rice or polystyrene ball on a vibrating loudspeaker. Cone that faces upward. Using a vocal cord. Or you can also feel your larynx vibrating. Two types of waves travel. Particle in the medium vibrates about their mean position, transferring energy but not matter. The two types of waves are longitudinal wave vibrating along the direction of transferred energy. In the figure you can just see one end is fixed F, okay, and one end is free of the spring. Okay, so you can just vibrate the spring along the direction of transferred energy. So the spring will travel along the direction of transferred energy and it will come in the backward direction. In the figure you can just see the longitudinal wave, and the second wave is transverse wave. The vibration is perpendicular to the direction of transferred energy, so the wave will move in the perpendicular direction of the energy transfer. Measuring sound. Frequency, the vibration for cycles per second. The unit is hertz or kilohertz. Amplitude, size of the vibration. Loudness, perceives the strength of a sound. So it is frequency dependent. Intensity of the sound is the energy carried by the sound, which is the unit is decibel. Representing a wave graphically. Displacement, time graph shows what happens to a single particle in the medium over a time. So in the figure you can just see the graph. Okay, it's a wave graph. Okay, so you have T half, this is full T, and you have a crust and you have a trough. So this part from the peak position to this peak position is known as the period. Okay, so which is denoted by T is the time for one complete cycle. Okay, so you can just see for one complete cycle it starts from origin and here it goes T half and it completes over at point T over here. Okay, so this is one time period. Okay, and the frequency is 1 by time period. Wave speed. Distance wave travels in a second, meter per second, is equal to wavelength multiplied by number of waves each second. Okay, so distance traveled in a second, the unit is meter per second, is equal to wavelength in meter into number of waves each second. And the symbol is mu, which is equal to F into lambda. To find the speed of the sound, measure the distance and the time. The speed of the sound in the solid is greater, and the speed in the liquid is greater, okay, and the speed in the gas. The speed of the sound in air depends on the temperature and humidity. Medium, not source, generally determines the wave speed. Refraction. As the wave travels from one medium to another, its speed changes at the boundary. So this is very important point. When the speed is getting changed, is it at the boundary? The frequency of the wave arriving at